All right, good evening, everybody. Welcome to tonight's webinar from the National Weather Service in Boston Norton. This is the 2022 Weather Year in Review, and I'm Joe Deli Carpini, the Science and Operations Officer. Along with me tonight is Bryce Williams, one of our meteorologists. So we are going to take you through the entire weather year, look at some of the more significant events that affected southern New England. You've got the usual reminders up there on the screen. Remember just to use the chat box for questions. And Bryce, we may pause after the winter weather section and take a look if there's any questions or comments for that, and then we'll move on to kind of the second half, which is severe weather. Just a quick note on the upcoming webinars there on the lower left. We did add a new one today. That'll be next Tuesday. We're on a string of Tuesdays for a little bit. January 31st, we'll take a look at the January 15th to 16th offshore storm. That was the one that, the big ocean storm that stayed offshore. Actually almost formed a little bit of what's called a warm core and was being considered as a subtropical storm, believe it or not. So we'll talk a little bit about that and show some of the model data too. And the model really struggled with that storm, which is pretty typical for those types of ocean storms. Then, of course, on February 7th, we'll have our Blizzard of 78 Remembrance. So you'll want to join us for that. Bryce and I found a lot of new pictures and some information. So we've got a really nice presentation ready. And further ahead in March, we'll be scheduling the 30th anniversary of the March 1993 Superstorm. Can't believe it's been 30 years already. So that will be coming up as well. And in the meantime, of course, more event reviews as we have some more significant weather. I know it's been kind of quiet this winter, but we'll also do our weather briefing at the end tonight. I think, Bryce, there's a little bit of weather coming up. Someone told me tomorrow. Okay, we'll talk about that.
I think so, a little bit.
Yeah. All right. So these are all the events we're going to talk about tonight. There's quite a few, but you'll see it's very winter weather heavy. 2022 was, fairly average, maybe a little bit more active from the winter weather standpoint. Of course, the big blizzard, was at the end of January. But really, the severe weather season was one of the quietest I've seen in my 25 plus years here at the Boston office. Really, one good severe weather event in July, one couple of flash flooding, and also one in late August. But the big story obviously was the summer heat and drought. We'll talk a little bit about that too. But definitely was more of a winter weather year, I think, than anything else. We were kind of surprised how quiet the severe weather season was. That's kind of an unusual thing. So the first thing we're going to do, I've actually got a couple of poll questions here, so we're going to try and see if we can get these to work. And we're going to start off. Let's see if we can get this to launch. It should. Hopefully you're seeing this, and we want to know, what was your favorite weather event of 2022? Was it the January blizzard? I'm having a feeling that's going to be the biggest response. Maybe the winter storm around Valentine's Day. We'll talk about that. That had some mixed precipitation. Maybe some severe weather. I don't know. We have some severe weather fans out there, I'm sure. Flash floods, or maybe just the storm just before Christmas, the big inland storm across the Great Lakes brought us wind and coastal flooding, and the rare ocean effect snow to Martha's Vineyard. So let's see. So far, it looks like the blizzard's in the lead by about 2/3. It's got about 68%, and I'm seeing 27% for July 12th severe weather. So we'll give it just another second, but it looks like, as much as I thought, Bryce, the blizzard would be right on top there.
You're right. That would be my vote.
It certainly would be my vote as well. That was a decent storm. Was that your first blizzard here, Bryce?
Yes, I've been waiting 4 winters for one. Finally.
Because you missed the January 2018 blizzard.
Yeah, I got here in August 2018, so just missed it.
All right, so it looks like the January blizzard wins with, looks like a final of about 71% and 25% or so on the July 12th severe weather. Okay, so let's close that one, and then I'm going to go to just our second question. So what was your biggest weather surprise of 2022? Was it the blizzard? Was it the fact we had a really quiet severe weather season, or was it the heat and drought? It's not unusual for us to have these periodic droughts, but the heat end of July and August was pretty extreme, if you remember that. So let's see. Oh, Bryce, looks like the severe weather season's taken the lead on this one, and I would kind of agree with that.
Seriously.
Yeah, so we've got about 59% of people showing that. 30% on the heat and drought. I would agree with that too. That was kind of surprising. It persisted for so long. And the blizzard is about 8 to 9%. So yeah, that's usually not too much of a surprise in late January and February. But yeah, it looks like the quiet severe weather season is the winner. And I'll tell you what, we were at the office, I think we were all ready to go, and we had a lot of new people who just had their radar training done and were ready to go, and we had nothing.
Nothing.
That's what Mother.
I'm hoping for some more this year.
Yeah. So we've got actually our newest forecaster, Kyle, is just finishing up. He'll be finishing up his radar training next month, so hopefully we can give him something to play with. All right. So we'll close the polls there. Thank you very much. We, as we mentioned, we kind of like to do these periodically to make this a little more two-way in addition to the chat messages. So we'll go over all these events. I'm going to hand it off to Bryce, who's going to cover us through the winter weather through the end of February, and then I'll come back and talk about the weather for the rest of the year. So, Bryce, I will hand it over to you.
All right. Thanks, Joe. Okay, so we'll take it back to start last year. We'll take it back a little over a year from now, because last year we started off January more quickly with a good snowstorm than we have this year. So our first real winter storm of the season was a quick hitter, but it laid down quite a bit of snow, especially along the I-95 corridor, just or just northwest of it a little bit. Providence didn't get quite there, but it laid down about a foot of snow from northeast Connecticut up through just south of Boston. And so this was the second week of February. It came in on a Friday, and this video in the bottom right was from one of our forecasters, Rodney, who is up in Burlington, Vermont now, and he was out doing what he likes to do, snow chasing. And this was in Attleboro, I believe. So it was coming down, really, you can tell, just really, really heavy with this system, 1 to 2 inches per hour. Now, looking at the meteorology of it now, we'll look at the surface low, and we see that the low intensifies right near that 70-40 or 40-70 benchmark. And that's kind of like we call it the benchmark because that's right where we want it for a good I-95 corridor snowstorm. That particular track is usually a good signal, and so this one happened to pass just over there, and as it was intensifying at the same time, so gave us a good signal for some heavy snow. Now, if we look a little bit higher in the atmosphere, 850 millibars. Remember, we measured the height through the atmosphere in millibars, constant pressure heights, but in feet, it's about 5,000 feet up. And so we look at the low up there, and we see that it was intensifying as well up in that level, but it was also closing off a little bit further northwest over Cape Cod and really the Cape Cod Canal. And so when we're looking again for if we had a benchmark per se for 850, that would kind of be it for being favorable for heavy snow in the I-95 corridor, because typically the heaviest snow will fall just to the northwest of that 850 millibar low. So then we're going to go up a little bit higher again, up to about 10,000 feet at the 700 millibar level. And we're looking at the wind speeds here, the wind direction and the wind speeds. And so we have some very strong southerly winds. And what that's doing is that's not only providing lift, but it's transporting very warm, moist air in at the upper levels, providing plenty of moisture in the levels that we need to be forming snow. So it's called warm advection when we have warmer air coming to replace colder air, and warm advection is a feature that will give us very strong lift. It's going to make the air masses lift, and when it lifts, that's when we get the precipitation out of it. In this case, snow. And in this case, the temperature is more favorable where that lift was for some very large snowflakes to form, because we had some very strong frontogenesis, which is a term you may have probably heard if you've watched these webinar event, especially the event reviews before, but just a meteorological term telling us where we're going to have the best chance of that really heavy snowfall to form. So looking at the frontogenesis, on the left-hand side, we see model data depicting where the model was. Oh no, actually, this is actually from SPC. So this was a meso-analysis. So this is analyzing where the strongest frontogenesis was at 700 millibars. And this is pretty classic for us because we tend to see, it's kind of counterintuitive. You'd think, oh, maybe right beneath the strongest part of the band is where we see the heaviest snowfall. But actually, the heaviest band of snowfall typically falls right along the cold side, so the northwest side of that band. And that played out pretty perfectly right here. You see the same area outlined in red where those radar returns on the right side in yellow, that's indicating the heavier snow right in that area just to the cold side of the peak, the core of 700 millibar Frontogenesis. All right, so that was a good one. Then we moved on to not so much a good one for the I-95 corridor, but this was more of an interior high elevation snowstorm. This was our next storm. About 2 weeks, a week or so later, I guess, a week and a half, from January 16th to the 17th. This was going from a weekend into the start of a week. And like I said, this was favoring the high elevations. And with this storm, we had not only had high elevation snow, which means we had rain along the coast, but we also had some strong winds that caused coastal flooding with this system. So you can see in this satellite, water vapor satellite image, the yellows, the oranges are showing where the dry area is, and the greens, whites, and blues are showing the moisture. So it's just that fire hose, we like to call it, of moisture coming down, stretching all the way from the Bahamas, so that it really had to tap into the tropics. So just a lot of moist air to squeeze out of that air mass. So looking again at the 850 millibar low, with this one, this was definitely an inland track, which makes sense as to why we didn't have the snowfall along the South Shore. And so it tracked up through Pennsylvania and into New York, west of New England, and that placed us beneath some very strong southeasterly winds. And those southeasterly winds are the reason that we were able to stay, that we stayed warm enough to just be rain for most of the lower elevations in southern New England, at least. So if we look now at the surface low, this is the track from the WPC maps showing the trajectory of this storm, and it started down in the Carolinas, and it was an inland track all the way up the eastern seaboard from the Carolinas up through Virginia, and then up into eastern New York. And so you can see that the L indicating the center of the low, with the warm front, which and the cold front indicated by the red and blue, respectively, and it also generated a secondary low, as you can see off shore of the mid-Atlantic and south of southern New England, right there, which can help sometimes to help enhance the lift and the dynamics for the system, but also sometimes it can help to reinforce some of the cold air. But in this instance, wasn't enough to keep cold air from retreating north for the lower elevations. All right, so then next in January, we had a busy January compared to this year. Looking at January 21st next, and this was a very localized phenomenon. It was pretty fascinating, actually. It was an ocean effect snowstorm, so it was very localized, really to Plymouth County for the most part. Was about the only county that was impacted. And you can see some of the totals here. We had a high total of 5.3 inches in Pembroke. But generally it was about 3 to 5 inches across, especially eastern Plymouth County. And the reason, actually, we'll get to the reason here in the next couple of slides. So you can see in the satellite imagery that we pulled, you can see, well, for one thing, you can see the wind shear, because you can see the upper level winds moving from southwest to northeast, those high clouds. But then the low levels, you can see these north-south oriented bands of clouds, even through the high clouds, and this is this can be pretty typical with this ocean effect clouds and snowfall. So it's because of this moisture that we're getting, and I think the next slide gets more into that. So yeah, so this really shows the banded structure as well. This is radar imagery, and so you can note that there's multiple bands. Again, it's pretty common for our ocean effect snow showers, and this is just due to the way that they are so shallow. They have very limited what's known as fetch over the water. So fetch is just the distance that the air mass has to travel over water and pick up moisture and whatnot. And so it's pretty limited in, from the Gulf of Maine into into Cape Cod Bay. But this is very dependent on very subtle changes in things like wind direction and wind speed. And so it has to be perfectly set up. And so we just happen to have the correct wind direction to direct this moisture in clouds right into Plymouth County in this case. So you can see this is a map of the surface observations at the time from 8 a.m. that morning. So we had an Arctic air mass in place. We had temperatures in the single digits, so very, very cold temperatures, and the single digit temperatures in the inland. Well, we had teens along the coast, maybe some 20s in Cape Cod, but still the difference between that cold air and the water provided enough instability for those snow bands to form. So it's because of the relatively warmer water beneath the very cold air that we get that. And so you can see not only did we have the just the right wind direction, but you can see actually some subtle low-level convergence right over Plymouth County, which provided some extra oomph to really squeeze the moisture out of that air mass. And when we say convergence, we're looking at the wind barbs that are basically the barbs are showing the direction the wind is from. So these would be northeast, north winds. And so even a subtle change in wind direction can cause enough convergence to enhance precipitation, whether it's snow or rain or whatever it is. All right, now to the biggie for the year, our blizzard to end the month. This came during the last. It actually was. I remember it being very well timed as far as impacts, because came in on a Friday into a Saturday. So luckily, a lot less people were out on the roads having to get to work and school, since it was mainly on a Saturday. And then Sunday, what I remember was nice and sunny, and so it was a great day for cleaning up and everybody to get out. And it was really nice weather to follow it before everything was cleaned up before next work week. So it honestly timed out pretty great. And this dropped about, let's see, I think I remember our highest total was in Stoughton. Oh, I didn't see that. Yes, the highest report was in Stoughton, 30.9 inches in Stoughton, Massachusetts. And so really the South Shore was the jackpot winner in this system, but honestly, anywhere in Rhode Island and eastern Massachusetts got up from a foot to 2 feet of snow, which was more than we've gotten in many years. And this picture in the bottom right is our office. And you can see some drifting in the snow around the cars here from the winds and the heavy snow that we had. So just a reminder for those that may not have heard this before, or those that need a reminder, in order to call it a blizzard, it's not just that a storm is snowy and windy. There's actually specific criteria that we have to have. There's 3. So for one thing, the visibility needs to be a quarter mile or less in falling and or blowing snow. So actually you could get a blizzard when it's not actually snowing. It could just be the winds are so high that the dry snow is blowing so much you can't see. And then speaking of winds, you need the winds frequently gusting to 35 miles per hour or higher. And then the predominant conditions, or these have to be the predominant conditions for at least 3 consecutive hours. So you can't have any gaps in there. But if it reaches 3 hours, then you officially have a blizzard. So places that we confirmed a blizzard based on the surface observation stations were in Massachusetts, Boston, Worcester, Beverly, Hyannis, Marshfield, and Martha's Vineyard. And in Rhode Island, Providence, TF Green, Westerly, Newport, and Block Island. So it was a pretty widespread blizzard event for Eastern Mass and Central and Eastern Massachusetts and Rhode Island. All right, so we made or tied some records with this system. In Boston, we had 23.6 inches, which tied the daily record snowfall set back on February 17th of 2003. The record for daily snowfall in January also and that was 22.1 inches on January 27th in 2015. So 2 records with that 23.6 amount, and then 23.8 storm total was the 6th highest of all time, compared to 20. Oh wait, hold on. The 27.6 is the highest, I believe, right? Is that what that is? The 27.6.
Yeah, and that should be February 17th to 18th. That's the blizzard of 2003. Yep.
Okay. Yeah. Oh wow, I didn't know. Yeah, that's a really long blizzard. February 17th to 18th. That's the record. So we are the 6th highest with this one. And then in Providence, we had 18.8 inches, which also set the record daily snowfall, beating, actually not by much, 18.3 on February 1961. And then it also was record daily snowfall for January here as well, beating the record of 16.4 in January 2005. And then 19.3 total was the 3rd highest of all time, compared to the highest, which it was 28.6 from 1978. And then finally in Worcester, we set a daily record as well. So rounded out in Worcester with 14.7, and that beat the daily record of 11.5 inches in 1973. So record-setting storm. So we not only dealt with the winds and the snow, but we also had coastal flooding. We had minor to moderate coastal flooding. So generally about 1 to 3 feet deep flooding during high tide for the eastern Massachusetts coast. So you can see some pictures here, one from Long Wharf in Boston, completely covered with water. And then one from Hull, Massachusetts, you can see trash cans floating. So this is a street, normally a dry street, and you can see it covered in water. So looking a little bit at the meteorology again, up at 500 millibars, about 18,000 feet up. So this is where we look at what we call the upper low for things like troughs and ridges. And so the upper low closes off near Cape Cod. And so this, again, is favorable for heavy snow to the northwest. That's the theme. Typically, the heavy snow is always to the northwest of these low centers. And so this tracked just right over Cape Cod, which was very, very favorable for having cold air in place and snow. So the surface, looking at the surface maps for this one, you can see this actually was what's known as a bomb cyclone. It underwent bombogenesis because the pressure dropped from 1,004 millibars to 969 millibars in 24 hours. So that was a change of 35 millibars. And to achieve bomb cyclogenesis, you need a drop of at least 24 millibars in 24 hours. So 1 millibar per hour. And so you clearly beat that. So it was a very strong storm, and that low passed off the right near the 70-40 benchmark again, and up into Nova Scotia. All right, so then into February, this was, I believe, the night of the Super Bowl, because I remember one of our colleagues having a Super Bowl party and coming home, driving to work for the night shift that night on Sunday night, and having a bit of a iffy drive from Rhode Island. And so this came in on a Sunday night into Monday, and it dropped almost up to a foot in northern Rhode Island, central Rhode Island, and in over towards the south shore of Massachusetts. So this was a challenge. I do remember this was a challenging storm as well to forecast. And one of the factors in that was that there was a lot of uncertainty and disagreement in the models of the strength of the mid-level wave or the trough that was moving through, that was going to be providing that lift and the mechanism to get that snowfall. So you can see some of that uncertainty on the left here. You have all these different colors are different models, depictions of their idea of what the trough's going to look like. So it's kind of all over the place, right? You've got some that are very shallow up into northern New England, and then some that are over southern New England, some that are way down in South Jersey. So a lot of differences in the outcome would come to pass if those different scenarios played out. And so looking at, and then this on the right is the Storm Prediction Center analysis of what actually happened. So you can see it was quite a deep trough that moved through. this is what the surface map looked like, showing the low pressure system at 1 p.m. Sunday offshore, and then 7 p.m. Sunday. You see the low at about 1,009 millibars, and then by 1 a.m. Monday, it is around it looks like it's around the 70-40 benchmark, and then it moves east. So it was you can tell it's not got the concentric rings and circles of the blizzard storm, which means it was a much weaker low, and those obviously the over 1,000 millibars is going to be a weaker low than the last system, so it's less organized, but it was enough to drop almost a foot of snow in Rhode Island. And you can see from this model sounding why we had such efficient snowfall with this system, because this is a model sounding. This is a simulation of what it would look like if we had launched a weather balloon during the snowstorm. And what we can see here is the temperature. The red is the temperature, the green is the dew point. So where they're together, the atmosphere is saturated. And so you've got pure saturation all the way up to about 600 millibars. And on the left-hand side, very left, you can see what we call omega. This is the basically, excuse me. This is basically the amount of lift available. And so those pink columns are the strongest lift. And so that best lift is right here in the maximum snow growth region, which is generally from about -10 to -20 degrees Celsius. So they've lined up perfectly with the best snow growth lift and in the best snow growth region with plenty of moisture. And so it really helped them overachieve on this system. Large snowflakes. Okay, then another flavor of snowstorm. We had some really neat snow squalls in the middle of February 19th, that rolled through central Massachusetts and all the way through Boston. There's some cool videos time lapses that came out of this. And you can see it brought whiteout conditions to a lot of people. That is especially dangerous when people are on the road and driving. And Joe, I believe, are the blue boxes, were those snow squall warnings, I believe?
Yes, that's true. That's correct.
Yeah, so as you see, as it's progressing east, you can see we were issuing snow squall warnings, mainly for drivers, because when you go very quickly from full visibility to no visibility, it can cause big pileups. So this is what we kind of looked at to give us an idea, that this is going to be potentially impactful. So this is the Snow Squall Parameter that the models give us. Basically, it's taking into account moisture and lift. So it's just like thunderstorms. It's kind of convective in nature, like we deal with thunderstorms in the way that what we look for in the models. And so it was showing a strong potential for snow squalls all the way from New York, all the way clear to the coast of Massachusetts and Cape Cod. So this is a graphic that we had put out, kind of showing the timeline of when we expected snow squalls, showing a high probability or a decent probability of them occurring, with a high impact if they did occur. And then you can see an example of the snow squall warnings that we did end up issuing when it panned out. So this is just some neat time lapses I'll let loop through a few times, just showing you. Now look at Boston, the Prudential Tower suddenly just disappears. So you can see how disorienting that could be when you're driving on the interstate very fast. And then the sunset comes out. That was a really neat time lapse I remember at the time, and it was happening right at sunset. So just a very cool phenomenon to watch play out from a tower cam like this. Whoosh. All right, and then our last storm for February was February 25th. This was actually occurred right after we had some record warm temperatures. But even so, this was not necessarily an I-95 storm, corridor storm, or a high elevation storm. This one actually, the peak of the snowfall totals were in northeastern Mass through Essex County. So where we had up to 10 inches or so. So in this case, the low tracked over northern New England. So typically that means that we'll have a transition from, to a wintry mix of precipitation. So the rain mixes in or the sleet. We had cold air initially in place. So that led to a burst of heavy snow as the storm began. Often we call that a front-end thump of snow on the beginning of it. And the blue and the red lines, dotted lines, you can see the very tight temperature gradient near the south coast. And this in itself implies some strong lift. Now this is a surface observation map again. This shows what we call a coastal front located over eastern Massachusetts and Rhode Island. So you can kind of see how we identify that is looking at the wind direction. So looking at the wind barbs that you see they're out of the east along the coast and in eastern Mass, and then just to the left of the west of the front, they're more out of the north and sometimes the northwest. So that's where that front sets up for some extra potent lift, and that goes right through northeast Mass, which is where we had the best snowfall totals. So it makes sense. And this was pretty much a stationary stationary front that kind of sat over northern Massachusetts, but it did eventually make its way into Connecticut. And you can see that this mild air caused the precipitation in Rhode Island to turn to rain. The rain, you can tell it's rain by there's 2 dots, whereas the X's mean snow, where there's snow falling. So looking at radar can also tell us where the rain snow line is, or where the rain sleet or mix line is. This is a product called correlation coefficient. And so what you can see is we've drawn the line there to highlight it, but you can kind of see where those bands of yellow are. That's the rain snow line. And so north of that line, it's purely snow. South of the line is where we had a bunch of sleet, freezing rain, and rain mixing in, bringing down those totals. And so that line made its way to the Mass Pike in the morning, and it was actually a little bit faster than what we were indicating. The models were indicating ahead of this, and that's a typical bias that we notice oftentimes with these kind of systems. All right, so that's the that was the winter. We'll see if we get a more active second half of the winter this year, but that was last year.
All right, let's Bryce, let's just take a quick pause here and make sure we have any questions. Let's see. Oh, someone wants to know if we can provide the link for the Boston Tower cam used for the Snow Squall video.
Unfortunately, we don't have that. We don't have access to that. We got that from Twitter. We asked.
That was from Sarah, I think, Roboleski, right?
Yeah.
Mm-hmm. Yeah, so that would be a WBC question, Robert. Sorry about that. But yeah, I don't see any other questions right now. So, okay, well, let's move on. Not a lot. Thanks, Bryce. You took the lion's share of this one. Certainly, quiet severe weather season, but this was probably one of our bigger days, July 12th. You can see a fairly solid line here on satellite moving across southern New England. Quite a bit of wind damage. You can see a picture here from a couple of locations out in Chicopee and Western Mass there. But overall, this was a fairly typical situation. The main key with this was we did have some instability, which we call the CAPE. In this case, this is called Downdraft CAPE. It's the amount of energy that's available to help produce downdrafts in the storms, which is the rush of wind that comes out. And then we also had strong wind shear, pretty strong jet stream for the middle of July. And this strong wind shear, which again is change in direction or speed with height, that can sometimes overcome, the limited instability that we have, and even what are known as poor lapse rates, or the change of temperature with height that we really want to see. Kind of all three. You want to see good instability, good lapse rates, and good wind shear. So if we have, fairly strong wind shear, that can compensate a little bit for the lack of instability, and it certainly did here. All right, that was pretty much all that event. Then in August, we had some good flash flooding. The first of 2 events. This was one that affected, Rhode Island, Greater Providence, over into adjacent parts of southeast Massachusetts. And one of our employees, Nicole, lives in Rehoboth, actually measured the highest rainfall from this. It was 7.44 inches, which was pretty significant. You could see her comments there from her observation. But you can also see this is I-195 west in Providence, was shut down because of flooding. Several of the roadways throughout Providence and neighboring areas of southeast Massachusetts were flooded. And this was a pretty classic setup. You'll see this theme also in the next flash flood event we talk about. I think, Bryce, even in our meteorology textbooks, this is what you see when we talk about flash floods.
Oh, yeah.
You have the stalled frontal boundary somewhere nearby, a good flow of moisture on the warm side of the front. You can certainly see that. The front's draped across Connecticut, Rhode Island, southeast Mass. We've got southerly flow, you can see by the wind barbs. And this is bringing in high moisture, kind of over that front. And this is providing your focus for lift. So this would help generate showers and thunderstorms, and a lot of which would move over the same areas. So just a classic, flash flood setup. And you can see here, this is the Mesoscale Discussion from the Weather Prediction Center. They had the area outlined very nicely right around that stationary front. And, talking about thunderstorms displaying training characteristics, meaning moving over the same areas over and over again, producing more localized flash flooding, especially in the more urbanized areas. So they were kind of all over that. And then something we look at is called, it's called the CREST model. It takes the radar estimated rainfall and looks at kind of the land use area that it's over. So, and it can calculate what's called streamflow, or the amount of water that's kind of, the runoff, in other words. So this pretty much simulates the runoff over paved areas when we talk about this hydrophobic streamflow, and it really helps us with flash flooding over the highly urbanized areas. So think about, Providence, Worcester, Boston, Hartford, those areas that are highly urbanized. And we see values over 300, orange and above. Flash flooding is becoming more likely, and certainly when it gets over 600, when we get into these purples and blues, significant flash flooding is likely occurring. And it did a very good job in Greater Providence over into areas of like Seekonk and even into Rehoboth. So it verified quite nicely. Okay, our other severe weather event was August 26th, and this was a little bit more of a widespread event. You can see on the radar loop here a couple of lines of thunderstorms moving through. These were all producing wind damage, pretty typical. But there were also some reports of funnel clouds. You can see a picture on the right there. This was over Providence. We had a couple of reports in northern Connecticut as well, but we'll talk about that really briefly. But there was, quite a bit of wind damage across the region, from eastern New York across much of southern New England, as where these W's are. But the main thing it did was bring some much needed rainfall to the area. Remember, we were in the midst of a pretty significant drought, and you can see some nice rainfall totals in excess of an inch in a couple of corridors, one close to the Mass Pike, another across northern Connecticut, down across the south coast and the islands as well. So this was really the first widespread beneficial rainfall we had seen in quite some time, other than that flash flood event we just talked about. So in the analysis here, I'm looking on the left at the instability, what we call our CAPE, and you can see quite a bit. We're over about 1,000 joules, which is pretty good across much of the area. Again, our wind shear is there. It's 40 to 50 knots, which is pretty good for that time of year. Focus more across northern New England, but we're kind of on the edge of the area here in Massachusetts, and the lapse rates were kind of meager. You want to see a little bit more than 5 or 6 degrees per kilometer. So again, it was the combination of the instability and this, particularly the stronger wind shear, that really helped fuel these storms over that day. So when we talked about the funnel clouds, here was a picture of Killingly that we received one. We had a few reports and a few pictures. We went back, looked at the radar data, and certainly you could see just south of Windsor Locks there was some sort of couplet. And keep in mind, we're looking up about 6,000 feet, so we're not getting a great look at it. But in investigating the damage a little bit further, it was determined that no, it was just straight line wind damage. There really was no evidence of any rotation or twisting of the debris. So there were some funnel clouds. There was enough shear for some rotation up in the mid-levels of the storms, and that's why we saw the funnel clouds, but not enough to bring it down to the ground and cause further damage. Okay, then our other flash flood event was more significant. This was on Labor Day for the most part, but lingered into Tuesday. This really affected downtown Providence, and you can see I-95 here by the Thurber's Curve, completely shut down, completely flooded after some heavy rainfall. And again, another classic flash flood setup similar to late August. We've got a stalled front over New England and a southerly, more of a southeasterly flow, this time of kind of tropical air running right up into the front. That helps generate showers and thunderstorms, gives them added moisture, and they tend to be slow moving. So they kind of, we say, train over the same areas and produce excessive rainfall. So here's a loop of the radar, and you can see on the bottom, this is your typical radar loop here. And then the CREST data is up at the top left here. So you can kind of see as the storms move along the front, they kind of redevelop, reform, and you start to see some higher purple values in this hydrophobic streamflow, which is telling us we've got some flash flooding going on. But notice how the storms just light up around where that stalled front was and really just repeat over the same areas. So you can see we've got estimated rainfall in the lower right here as well. So again, as this loops through, storms form over Connecticut, ride along the boundary, and just kind of go over the same areas and produce the most excessive rainfall over the greater Providence area. So I'll let that loop through just one more time here so you can see that. Okay, and just zooming in, here's the look at some of the 24-hour rainfall amounts. The image is kind of the radar estimation, then we've put some observations in the top, but you can see in northern Rhode Island, 6 to 9 inches of rain, and most of that fell in just a few hours, which is pretty incredible. But really the area from southern Connecticut up into Rhode Island, and even parts of nearby eastern, southeastern Massachusetts, really excessive rainfall in the order of 5 to 9 inches across much of that area. Again, much of that fell in just a few hours. And then speaking of the drought, well, we'll finish up a little bit about that. Starting in late May, we were kind of starting to dry out, but we were still getting fairly average precipitation. It really was in June when we started to dry out, and you can see by the end of August, much of the area was in the D3, which is the severe drought category. D2 out in much of western Massachusetts. They did receive enough rainfall from showers and thunderstorms that it helped a little bit, not too much, but the eastern areas really dried out and didn't see any substantial rainfall throughout much of the latter part of June into July and even August. So just taking a quick peek, this is some of the accumulated precipitation for the whole year. And you'll see we started off, right around normal going through the winter with all the storms that Bryce talked about. And then we started to dry out in spring, and really the departures just took off as we went through the summer with the lack of rainfall. And you can see a similar trend here in Providence. It took a little bit later for it to get going, but it certainly did in July. You can see the normal is the brown line and the observed rainfall is the green. So if we're below that, that's below normal rainfall. And even across the interior, a little bit less of a signal, more normal rainfall up into early June or mid-June with showers and thunderstorms. And even those areas started to dry out after the 1st of July. And even in Worcester as well, you can see, again, more frequent showers and storms here throughout May and June. So it helped a little bit. But even those areas did dry out as we got into July and especially August. So, when we talk about droughts and hot and dry weather, you remember the end of July into the first couple weeks of August was a lot of excessive heat. Well, we have what's called a blocking high pressure ridge that's, present somewhere, and it circulates hot and humid air. Sometimes it's over the southern plains. Sometimes it's off of Bermuda. That's known as our Bermuda high. But the prevailing summer pattern, this is kind of an animation of some of that here, shows more of a ridge. You can see the wind barbs kind of showing where the high pressure is. It was over the Rockies and would occasionally move into the southern plains. So our heat was actually coming from the west, not so much from the south or like into the tropics. So it was more, I want to say a dry heat, but we certainly had a lot more heat making its way across much of the country, which is a little more unusual. We tend to see it, come from more from the south. Okay, and then we'll finish up here with a look at our December storm, which was just a few weeks ago. And we do have an event review of this. We had damaging winds across much of southern New England, minor to moderate coastal flooding on both coasts, which is fairly unusual. And then behind the storm, there was a blast of Arctic air, which produced a rare single band of ocean effect snow on the Cape and the islands, and particularly on Martha's Vineyard. So many of you will remember this just before Christmas. Fairly widespread wind damage, down trees, branches, power lines. This was in Norton, the town square. This was damaged. I think it was the bandstand. And the coastal flooding was, pretty significant. Fairly, I would say moderate, which is, 2 to 3 feet deep from much of the North Shore down through Boston, down through Scituate and Plymouth, and onto the Cape and the islands. Fairly significant flooding, and also onto the South Coast too, which is pretty unusual to see for both times. And in our ocean effect snow event, this is an animation of the satellite. You can see different bands of snow, but here's our main one from Long Island Sound across Block Island to Martha's Vineyard. Really dumped quite a bit of snow. It was probably the most impressive single band I've seen in my time here at the Boston office. Typically, we see much weaker bands as Arctic air is departing, not so much as the air is coming in. So having those winds out of the west-southwest was certainly an unusual event. And, tops were 9.5 inches in Chilmark on the Vineyard, but you can see several inches of snow throughout much of the Vineyard and even on the parts of Cape Cod as well, although they escaped really the worst of it. The band was moving around quite a bit more up around Cape Cod. So the Vineyard was the big winner on that, and they ended up having a white Christmas on the island, which was kind of nice because not everybody saw that this year. So with that, that is a look at our weather year in review for 2022. So we will take a pause here and see if we have any questions, and then we'll get ahead to our weather briefing. So let me just see. We have a question, looks like from JP. Are training storms more of a threat with global warming? Well, good question. Always hard to pin a particular event on global warming or climate change. I think that's certainly more likely because we know here in the Northeast we have warming temperatures. We know we have more frequent heavy precipitation events. That's pretty much been documented. So yeah, there are certainly, the odds are higher. You have to look at it almost in like looking at chances, and the chances for our region of the country to experience that is certainly higher than in other parts. So yeah, there is some correlation. You can't say directly these two events were directly linked, but certainly the odds favor more types of these events in the future. And the other part of the puzzle is too more urbanization. So notice our most severe flooding was in Providence. We've had more urbanization. We're building more. We're cutting down trees, more building of things like malls and houses, and so there's less room for the runoff to be absorbed into the ground. It's just going to be pure runoff over paved areas. So that's another part of the issue as well. A good question. All right, Bryce, I don't see anything else. So I think at this point we will take a pause here.